Alright, Algebra 2s, let's see how we do on this homework. If I want the fourth root of 25 squared, that's the fourth root of 5 times 5 times 5 times 5. Therefore, my answer is 5. That's my rational exponents rule. I'll come down here. If I have 10, this exponent means that this is going to be times 125 to the positive 1/3, which is 10, times the cube root of 125, which is 5. So we'll go with 50. Here's my radical addition rule. My practice for this says if they have the same index and radicand and variables, I can add them. This is a problem, but the good news is I can solve it, or I can simplify this. So when I simplify this, I can bring 1x out, leaving me with the fourth root of 3x, which means I have 5x times the fourth root of 3x plus x times the fourth root of 3x. So 5x plus x, I have 6 x's times the fourth root of 3x. Cube root of 16, 16 has 4 2's in it, which means 1 2 comes out, and I have the cube root of the other 2 plus 5 cube roots of 2. Because my values match, all I need to do is add my coefficients. That's going to give me 7 cube roots of 2. Alright, here's our radical subtraction rule. Again, I'm going to have to simplify these and hope I can make them match. 8 is 4 and 2. 4 is a perfect square, so it can come out from under the radical sign. Negative 2 times this 2, square root of 2 is, oops, this one's not negative. Negative 4 roots of 2 minus 50 is 25 and 2, so 5 comes out, which means it's negative 4 minus 5 roots of 2. That sounds like negative 9 roots of 2. 12 to the 1/2 power minus 27 to the 1/2 power. That's the same as the square root of 12 minus the square root of 27. 12 is 4 and 3. 2 comes out. That's a perfect square. 2 roots of 3 minus 27 is 9 and 3. That's a perfect square. It comes out. 2 roots of 3 minus 3 roots of 3 is going to be negative 1 root of 3. Our radical multiplication rule. So my indexes match. I don't have any negatives or i's to worry about. So I can take these coefficients, multiply them and bring them out. And then everything else can go under one radical sign. Now notice I'm not going to bother simplifying. I'm going to take my coefficients first. And then I have 2 x's and I have 3 y's and I have 4 z's. Which means this perfect square can come out, and it comes out as a 2. So then negative 8 times 2 is negative 16 x. These x's come out as 1, so that adds another power on there. 2 of these y's can come out. 2 of the z's can come out, and what's left inside the radical is this 3 and 1 of the y's. square root of negative 5 times the square root of negative 125. We'll first bring I out. I times I is negative 1 times the square root. Now I can put everything together. 5 times 125. I know that 125 is 3 5s. So I have 1, 2, 3, 4 5s, which means it can come out as a factor of 2. So my answer is negative 1 times positive 25. My answer is negative 25. Alright, let's take a look at page 2. Here's my radical division rule. And for my radical division rule, if my indexes match, I can go ahead and put them under the same sign. I have 6 over 48. I can simplify that to 1/8. The cube root of 1 over the cube root of 8 is going to be equal to 1/2. Number 10, express your answer in simplest radical form. So I'm going to go ahead and take, see if I can simplify things. My variables don't simplify. But when I look at 343 and 27, I'm wondering if they're friendly numbers. So I'm going to go ahead and use my calculator to see. 343 divided by 27. Nope. But I know 343 has factors of 3. So I'm going to see 43 divided by all the values of x. Go to the table of values. And when I look at its numbers, it's 7 and 49, which means this is a perfect cube. So when I just share out this power, 343 to the 1/3 power, and x to the 5/3 power, all over 27 to the 1/3 power, and 9 to the 9/3 power. 343 to the 1/3 power we saw was 7. X, when I go to simplify that, 3 x's come out as 1, and it's going to leave 2 x's inside. I had 5 x's. Here's 1, 2, 3, and inside 4, 5. In my denominator, cube root of 27 is 3. Y to the 9/3 power is y cubed. Alright, when we rationalize these denominators, I can't have a radical in the denominator, and this is not the square root of 4, it's just plain old 4. So instead what I need to do is I need to multiply it by a form of 1 that's going to give me the factors I need so that this can be simplified. So I wind up with 4 times the square root of 2z over, now when I multiply this, I wind up with 2 times 2 is 4, square root of 4 is 2. Z times z is z squared, square root of that is going to be z. These coefficients can be simplified, so I wind up with 2 times the square root of 2z over z. These z's cannot be simplified because this z is under the radical. It's not z, it's the square root of z. Those are not the same thing. Alright, I can have the square root of 9x squared over the square root of 16y. This simplifies to 3x. This simplifies to 4 times the square root of y. when I use my form of 1, I have 3x times the square root of y over 4y. Root y times root y is square root of y squared, which is equal to y. One more fun extra problem. Express your answer in simplified radical form. So this is interesting because this is 2x all to the 1/2 power. And this is 2x all to the 1/3 power. Same base means I add my exponents. In order for me to add my exponents, I need to have a common denominator. So if I turn 1/2 into 3/6 and I turn 1/3 into 2/6, now I have a common denominator. So that's going to be 2x to the 5/6 power. Remember, they asked for it as a radical, right? So we're going to go ahead and say, if I had an index of 6, 2x to the 5th. That's a great extension problem. We can talk about that if you want to come ask questions.